Hi, pre-calculus kids. We are going to talk about operations with rational functions right now. So let me pull up this. All right. So we've been talking about multiplying, adding, subtracting, and working with complex functions or complex fractions rather. So I just want to do some practice if this is something that you need a little bit more practice with. All right, so first thing we always want to do here when we're looking at these, we want to simplify, is we want to factor anything that can be factored. So you can factor using a box, or if you want to just kind of guess and check, you can do that. This would be a -3, this would be a +1. And I'm just going to get the factors down here. So here are my factors. And what we're looking for is what CP/M calls a giant one. So I can rearrange this into x minus 3 over x minus 3 times 4x plus 1 over x plus 2. So if you multiply across the top, that's equivalent to this. If you multiply across the bottom, that's equivalent to this. So we're allowed to do that. The reason we want to do that is because right here, anything divided by itself is equal to 1. So CP/M calls that a giant 1. So it's like having 1 times 4x plus 1 over x plus 2. Okay, now sometimes it will turn out that you can maybe factor more and do some more giant ones, but in this case, we are done. Well, except for one little thing, we want to state what our excluded values are. Excluded values are anything that would make the denominator 0 starting from the beginning, right? Because in this expression right here, it's undefined whatever would make the denominator 0. So it's maybe easier here to tell what would make the denominator 0, and that would be 3 and -2. So I want to exclude the 3 and the -2 from my answer. And so that is what I would have here. So that's just a basic simplifying. And then we move into, we can multiply, we can divide. All right, so let's do a division. When we divide fractions, it's the same as multiplying by the reciprocal. So I'm going to kind of do two things at the same time. I'm going to factor what I can factor. So I'm going to do some factoring, and then I'm going to remember this division, change it to multiplying by the reciprocal of this. Okay, so here, let's see, this would be 5x, this would be x. I need -14, so I'm going to put a -3 here because that would be -15x, and then put a +1 here, that's 1x, so -15x, and 1x is -14x. This right here, x squared minus 9, remember your friend difference of squares. If you have a squared minus b squared, that's the same as a plus b times a minus b. So lots of factoring shortcuts out there in the world, and some of them really not worth really memorizing. This one is because it comes up all the time. So that would be x plus 3 times x minus 3. Right here, when I factor this, this here is going to go in the denominator of my fraction here, and this is going to go in the numerator. So let's see here, I'm going to do the top. I have a 5x and an x, and the only way to get to a 1 is a 1 and a 1. So that's a 1x and a 5x, which is 6x, that works. All right, then this one, say I want a +1, so I've got to have a 1 and a 1, but it's a -1. Say 2x times, I want it to be positive in the middle, so this is going to be my positive, so that's 2x, and then it's a -1x. All right, so now I'm multiplying. Well, that means just straight across the top, straight across the bottom, so I can kind of connect these. And anything where I have the same thing on the top and the bottom, I'm going to think of that as a giant 1. So for example, in this one, I see these two here. Now, I know some of you are going to be like, oh, I can just cancel these. And I mean, absolutely, go ahead and do it. I'm going to just, for the sake of being really clear about what's happening, I'm going to rearrange things and really show those giant ones. So as you're moving forward, hopefully get away from needing to do this. But for now, I'm going to really show where things are coming from. So I see a 5x plus 1 and a 5x plus 1. So I'm going to put those over each other. Here I see an x minus 3 and an x minus 3. What else? I see this x plus 1 and x plus 1. Right? The thing with multiplication is it does not matter the order you do it with. So I've taken care of this one and this one And this one, let's see, on top I've got a 2x minus 1. And let's see, I've gotten this one, and this one, and this one. So then I also have an x plus 3 down here. And look at all these, giant 1, giant 1, giant 1. So I'm left with just 2x minus 1 over x plus 3, but I need to give my excluded values. And when I give my excluded values, that's really like I'm looking really here is the easiest place to look. Oh, I meant to change my color and I didn't. Right? It's easier to look at them in factor form. Anything that would make this equal 0, any of these equal 0, has to be excluded. Here, if you're looking at this saying, I'm not sure what makes this equal 0, then just set it equal to 0 and solve a quick equation. I just think in my head I would subtract 1 and divide by 5. So it can't be, these are all excluded, negative 1/5, and then x equals, or it can't equal negative 1. Okay, so here is my solution. Okay, so I simplified it all down. All right, now here's another one where we're simplifying. It's multiplication. So just straight across the top and bottom, but for anything you can factor, you always want to factor. So looking at this on top, I see I could pull out a GCF of an x, be left with x squared minus 16. And now I'm noticing those are perfect squares, so I'm going to come back to that. And then here I have 3 minus 2x. And then on the bottom, let's say about a 2x, and I've got an x. And 12, I have to get a 5 here. Okay, so I'm going to put a 4 here because that would be an 8x. And if I put a negative 3 here, that's a negative 3x. So that's 8x and negative 3x, that's 5x. Okay, so I got that factored, but I can, right, this can be thought of as x plus 4 times x minus 4. And let's see, I'm seeing this x to the 5th and I see this x here. So I think I'm gonna go for splitting that apart and thinking of that as there's a giant 1 right there, this x, and this I'm thinking of as x to the 1st times x to the 5th is x to the 6th. So I see a giant 1 there. And I think I'm just gonna rewrite this for now. Well, I see now I see here and here. I've got this 4, x plus 4, and I've got this x plus 4 right here. So there's another giant 1. So this is gone now, right? That's just 1, goodbye. This, I'm gonna write it out this time, right? We're gonna get away from it, but I'm gonna go ahead and do it. Okay, so I've got these two. I'm still on top. I've got this x minus 4. I've got this x to the 5th. Right, and then I've got this. They look really close, but they're not exactly the same. So I'm just going to kind of leave that for now. Here is a giant 1. I'm going to get rid of this. Okay, I see they're really, really close, but they're not the same. And so I'm going to pull another trick. I'm going to multiply. I'm going to add in a giant 1. Usually we use a giant 1 to get rid of things. Here, I'm going to add 1 in. I'm going to multiply the top and the bottom by negative 1 over negative 1. So this is a giant 1. Here's why. These are so close to being the same. This could just be flipped around. So if I multiply each of these by negative 1, I get negative 3 plus 2x. So now what I've got going on here, I've got this x minus 4 still over this x to the 5th. And now I have 2x minus 3, right? This is the same as 2x minus 3 over 2x minus 3. Okay, I multiplied this one in and that gave me that, but I haven't done anything with this. So I'll just kind of keep that times negative 1 on the bottom. Oops, that's not what I meant to do, but it's okay. All right, so now here, right here, just this is a giant 1. And then what I'm left with on top is I have x minus 4. And then here I have this x to the 5th times negative 1. So negative x to the 5th. And I want to go back to like all the way over here, I think will be the easiest, or maybe here actually, where I have this denominator factored. And I want to think about, all right, well, what are my excluded values? So what make this equal 0 would be just 0. And then what would make this equal 0? So it can't be 0. It can't be 3/2. And here it can't be, sorry, -4. All right, so there's my answer for that one. All right, now we get into, wait for it, adding and subtracting. Okay, so adding and subtracting, we need a common denominator. So I'm going to put this over 1. So my common denominator would be, let's see, I want them both to have an x plus 3. So to have this have an x plus 3 as the denominator, I need to multiply the top and the bottom by a giant 1 of x plus 3 over x plus 3. So now I have 5 over x plus 3 minus 4 over x plus 3. And when we add fractions, so like if you had something simple like 1/3 plus, I don't know, 4/3, right? You would say you have 1 plus 4 is 5/3. So when you add fractions, you keep the denominator. And then, whoops, what did I forget here? The x plus 3. Somebody was probably in the background shouting, you brought the x plus 3. Okay, so then when I go across the top here, you have to go across the top here, it would be 5 minus 4 times x plus 3. Notice I put this x plus 3 in parentheses because this minus 4 has to go to both of them. So I have 5 minus 4x minus 12 all over x plus 3. And then I can simplify on the top. So I have -4x minus 7 over x plus 3. And we want to, again, wait a second. Yes, I did. Okay, sorry. We want to, again, include any excluded values. So when I look at my denominators, I cannot have x equal to -3. You know what, I'm screwed. What I did wrong, I actually did do something wrong. I wrote the original problem down wrong, and I was just double checking my answer and noticed it was different, but that's because my original problem was different. But we did this correctly, so that's what's important. But if you were comparing to 3.7a in the book, this should have had a 5x on it. All right, now B, we're subtracting. That one looks more complicated. When you are adding or subtracting, you always want to factor the denominator before you start with your common denominator. And I guess I didn't mention that here because we didn't have anything to factor. And this one we do, the 16x squared minus 1. That's another a squared minus b squared equals a plus b times a minus b. So I'm going to factor, we don't have to factor the top. That doesn't matter. It's really the bottom that's important. Okay, so I'm going to have 4x plus 1 times 4x minus 1, and then minus x minus 2 over 4x minus 1. Okay, I want the denominators to be the same. The reason you want to factor is because you notice now that both of the denominators have a 4x minus 1 as part of them. So when I go to multiply by my giant 1, it's only the 4x plus 1 that this needs. If you had just multiplied this by the 16x squared minus 1 and that by this by the 4x minus 1, you end up with something more complicated and more difficult to simplify. You want the lowest common denominator. I'm going to put this guy in parentheses. Okay, so now my denominator would be 4x minus 1 times 4x plus 1. And then on top, I'm just going to bring this down minus whatever this comes out to be. So if we were to multiply this out, like make a box or just double distribute, like x times 4x is 4x squared, x times 1 is 1x, -2 times 4x is -8x, -2 times 1 is -2. This would be 4x squared would be minus 7x minus 2. Or if you want to make the box, go ahead and make the box. What's important here is that you put it in parentheses because you have to subtract everything. And if you don't put it in parentheses, you're not going to remember to do that. You'll just subtract the 4x squared and not everything else. Okay, so let's write this out. We would have 4x squared plus 5x minus 5, and that would be minus 4x squared. A minus would be plus 7x, and then again, a minus would be now plus 2, all over the 4x minus 1 times the 4x plus 1. Okay. In the end, you could ultimately simplify that. If you want to expand it, you could. I always let the denominator ride as in factored form until the end, because sometimes it will turn out you can factor the top, and maybe you can do some giant 1 canceling. So I always wait till the end. All right, so I see 4x squared and a minus x squared. Those are opposites. And then I see I have a plus 5x and a plus 7x. That's going to be 12x. And I see I have a minus 5 and a plus 2. That's going to be minus 3. And I'm going to just leave my denominator alone. I do notice that the 12x minus 3, there's a greatest common factor of 3. So I can pull a 3 out of these each, and I would have 4x minus 1. Oopsie, here's what I'm talking about. You see how now you're getting a giant 1 there. Those are gone. Now, the important thing when you're canceling, you're doing this idea of giant 1s, it only works with multiplication. So let me finish this and then we'll talk about it. So here again, what would make the denominator 0 going all the way back would be here. I couldn't have x be 1/4, or it also can't be negative 1/4. All right, here's the trap that you cannot let yourself fall into. Let's see if we can find one here. Here's what people always want to do. They see things like, well, where is there one? There's got to be one somewhere here. I see these things like here, they're like, oh, 4x squared divided by x squared is just x. And they say, oh, these things just cancel. And they don't cancel unless it's multiplication. Okay, when things are being added and subtracted, let's see, like this. If I have x plus 1 over x plus 1, or x plus 4, let's say, here's what people want to do. They would be like, bam, that's gone and equals 1/4. Okay, but that's not true, because if, let's say, x were 3, would you say 3 plus 1 over 3 plus 4 is 1/4? You would never say that, right? You'd be like, oh, that's 4 over 7. Okay, you can't just cancel things over addition. And I get why you want to, because it works with multiplication. Like if you had x times 1 over x times 4, that really does equal 1/4. Like if I put 3 in for x, 3 times 1 over 3 times 4, that's 3/12. That is 3/4. It works with multiplication. It does not work with addition and subtraction. So just be really careful of that, because it is so easy to fall in that trap. Do not let yourself get tricked. All right. I was going to talk about complex fractions in this video, but what I think I'm going to do is I think I'm going to stop this recording, and then I'll just make a separate video with that, because this is getting too long.